Today's notes are going to be on Module 2, Section 5. We're going to focus today on solving systems using a method called elimination. And we'll explain this, and again, like the first video, it probably will be more readily understood as we look at examples. But you want to have stacked equations, basically, is what I would tell you to think about for this. And so you want the x of one equation above the x of the other equation, the y's above each other, and then the numbers above each other. So you want them to kind of be stacked, so there's an x over an x, a y over a y, or you want them to be in standard form. And so notice here, the x is over the x, the y is over the y, they're in standard form, right? And so this is a basic example here, because I want one of the x's or y's, I need them to be the same number but opposite. So one positive and one negative. So here I have, they're both 4, one positive, one negative. And then I'm just going to treat the whole thing like one big addition problem. 5x plus 3x is 8x. Right? 4y, negative 4y plus 4y is 0. 33 plus 7 is 40. I divide both sides by 8. And I get x equals 5. Now, I need a y answer too. Remember that the answer to systems of equations is the point where the lines cross. All right, I'm not looking at a graph, but I know that my answer is still a coordinate, a point. And so I need to plug 5 back in. It does not matter whether you use the top equation or the bottom equation. And so I'm going to plug 5 back in, and I'm going to choose the bottom equation, just because to me it looks like it's going to be a little bit easier to work with. There's no right or wrong answer to that. You could totally have popped it back into the top equation. And so 3 times 5 is 15. I'm then going to minus the 15 to both sides. Remember, both sides means both sides of the equal sign. And so 4y equals negative 8. I then divide by 4 on both sides, and I get y equals negative 2. And so my answer is 5, negative 2. The coordinate, 5, negative 2. So again, because they're stacked, I just add them up. This one worked really nice because they immediately canceled out the y's. I had an answer for x super fast and easy. I had to plug it back in to solve for y. This one's slightly different. Notice it's still stacked, x over x, y over y, number over number. 9s are the same, so I can get rid of the y's again, still fast, but they're not opposite. Now, I could think of it as one giant subtraction problem, but there tends to be mistakes happen, especially for kids that struggle when you do that. But if that makes sense to you, that works just fine. What I'm going to do is I am going to times everything on top here by negative 1. That gives me a new equation. It gives me positive 2x, positive 9y, and positive 25. And so now I can work with these two equations. So I change the one equation so that I can work with these two, because now the 9s are stacked, but one's negative, one's positive, they'll cancel out. And so I'm going to add up the two equations. I have negative 4x plus 2x. Negative 4 plus 2 is negative 2. So I have negative 2x. The y's, negative 9 plus 9, cancel out. So the y's cancel out. So equals negative 23 plus 25, or 25 minus 23 is 2. I divide by -2, and I get x equals -1. Now I have to plug that back in. It does not matter whether you plug into the original one here, the original one here, or the original one here. It does not matter. You can plug in wherever you so choose. I'm going to plug into the -4x minus 9y equals -23, because that's the one I didn't change, so I feel most comfortable in there, but there's no right answer. So 4 minus 9y equals -23 minus the 4 across. And so I get -9y equals -27. Divide by -9, and I get y equals +3. That leads me to my final answer. X is -1, y is 3. That coordinate is my answer. You go ahead and try this one. Pause the video to give it a try. All right, I'm going to work through it now. Hopefully you have paused the video and given it a try. And again, I would change the top equation. I would make them all the opposite, so I get the negative. All right, so I would change that by making them all opposite. So now that when I add them up, they cancel out real fast. I get -x equals -6. So that gives me x equals 6. All right. I plug that back in. 7 times 6 plus 2y equals 24, which is 42, plus 2y equals 24. Minus 42 over, I get -18. And then when you divide, you get -9. And so 6 comma -9 is the correct answer to the you try. I hope you were able to get that successfully, or at least follow along as I did it. Now, this is from the last presentation, and it still applies right now. All right, there's special cases. So when you cancel out the x's or the y's, and both of them cancel out. So now there's no x's and no y's. There's no variables, no letters left. Once all the letters are gone, what is left is either going to be true or false. So it could be like 0 equals 0 is true, or it could be like 0 equals 7, and that's false. Right? And if it's true, it's infinitely many. If it's false, it's no solution. And so let's look at this. Now, for this one, I need to change an equation. And so I'm going to multiply everything in this bottom equation by -3. Because to me, that's going to make the x's cancel out. I have 18x, and -3 times 6 will be -18x. And so I'm just going to rewrite the top equation, because I'm not changing it at all. And then I'm going to rewrite the bottom equation after timesing everything by -3. So -3 times 6x is -18x. -3 times 7y is -21y. And -3 times 2 is -6. And now I can add them up. And those cancel out, so it's 0. And those cancel out, so it's 0 equals 8. And so I basically have 0 equals 8. Which is false. That's not true. And so I would say no solution. And then this is the last example we'll look at today. This is why I love elimination. All right. This was not be easy to use substitution. You're not going to be able to solve for x or solve for y easy. It also, they're stacked. They're stacked, so that's nice for elimination. But nothing is the same. X's are, 6x and 5x are not the same number. 5y and 9y are not the same number. So, and it's not easy to switch. I can't just times 5 by 2 and make 6 or anything. And so I'm going to get the x's the same. I'm going to times everything on top here by 5. And I want to times everything on bottom by -6. Because that's going to give me 30x and -30x. And so that's what I was looking for. And so 5 times 6x is 30x. 5 times 5y is 25y. And 5 times negative 32, grab that calculator. 5 times negative 32 is negative 160. On the bottom one, negative 6 times 5 is negative 30x. Negative 6 times negative 9y is positive 54y. And negative 6 times 26, grab that calculator. Negative 6 times 26 is negative 156. I add these up now. The x's cancel. This becomes 79y equals negative 316. I divide by 79. Negative 316 divided by 79 is negative 4. And so now I plug in. Now the good thing is when I go to plug back in, these are huge. So I want to use the original problem, right, to plug back into. And so I'm just going to plug back into the top one, 6x plus 5y, but y is negative 4 now, equals negative 32. So 6x minus 20, because 5 times negative 4 is negative 20, equals negative 32. Add 20 over, I get negative 12. Divide by 6, I get negative 2. And so my answer is negative 2, negative 4. And so that's a difficult problem no matter how you solve it. Just like before, I'm not going to try to give you too many that are super hard. There is one on today's homework I think is pretty challenging. But they're longer than harder, and I can't do anything about that. You gotta get through it. You can all do this, all right? And so best of luck to you. That was my workspace, and so it's like, okay. So this is the homework assignment. Good luck.